Good evening, guys. Am I audible? Is my screen visible? Can we start with today's class? Please give me confirmation, guys, so that we can start with today's class. So in the previous classes, we are seeing about project. So today also we are going to see one different project, that is nothing but time series forecasting. Okay, based on the time, we are going to forecast or predict the future based on the past data, and there are certain different algorithms are applicable for here, so we are going to deal with that also. Okay, so this will be just an introductory and we'll try to cover with simple example how it is happening. Okay, if you want you can explore it more. So I hope I am audible. Can we continue with today's class? Sorry for the delay, it won't happen again. So today is day 15 of Data Science Naan Mudhalvan Virtual Internship, and I welcome you all on behalf of Pantech elearning. Okay. So today we are going to see a machine learning time series project. Okay, time series forecasting, some more topics like this or that. So with this we will be completing the basic machine learning. From tomorrow onwards we are going to go into deep learning and NLP. That will cover the next 5 days. And please make sure you are attending today's class till end, because I am going to give you another assignment today, assignment 3. So it is going to be just a continuation with assignment 2, so that you can do it easily. So what we have learned in this week, we are going to implement it. Okay. So we'll start with this project. So before that, you have to understand what is this time series prediction, and we are going to see some model which is known as ARIMA model. So how or what it is. So time series prediction is a type of machine learning task, okay, where the goal is to forecast future values of time based on the past value. Okay. So a time series is a sequence of data points collected at regular intervals over time. For example, it may be daily stock price or hourly weather readings. Okay. It will be in a regular interval of time. So the time limit may be months or hour or minute, okay, or year. So based on the data you are collecting. So with that we are going to analyze the trend. Okay, you would have seen, right, the stock price, like this image, you would have seen the stock price. It may go on, keep on increasing or decreasing. You can see the trend, and they used to say whatever happened in the past is going to repeat. Okay, they will be finding some pattern. So if that pattern is available, so the future can be based on the past pattern only. So that's what in the stock market they used to say. So what we are going to do, we are going to take, for example, we are not going to use the stock market in today's class, but for example, if you are having a stock price, okay, for a company, for example, you take about Amazon or Reliance, whatever the company may be. So you are taking their data for the past 20 years, okay, you are plotting it and you are giving it to the model to analyze, so that you can do the same. Okay, if some part is repeated, okay, you can predict the future. Okay, it is like a regression, it is a continuous variable, right? You are going to predict the cost. So it is a continuous variable. So machine learning models can be used to make accurate predictions by learning patterns in the historical data. Okay, we will be already having some data. So with that we are going to forecast the future value. So these kind of problems or these kind of data, this data science is called as time series prediction or forecasting. Is it clear with the introduction part? Can I get thumbs up, guys? Is it clear regarding this one? Because in today's class this will be a time series introductory only, not that much elaborate. So we have to cover a lot of terms which you want to familiarize. Okay, I'll tell you what it is. So we have to understand those terms, then only you can analyze the project. So we will be seeing some basic project only. So I'll show you how it is happening, how it is done. If you are interested, you can explore more about it. Okay, can I get thumbs up, guys, in chat box? Waiting for your response. Okay, yes, thanks for the response. I hope we can continue with the class. I hope the introduction will be understood. So next, going into the algorithms which you are going to use here. So there are various machine learning algorithms that can be used for time series prediction, such as something known as autoregressive integrated moving average, which is called as in short form ARIMA. Okay, And some advanced feature in that is nothing but seasonal autoregressive integrated moving average, which is called as SARIMA or SARIMAX. And then some of the neural networks such as recurrent neural network or long short term memory neural network. So these neural networks we haven't covered it, so we'll try to cover it in the further classes. So once we complete that, we'll try to employ that in this time series prediction. Okay, so we'll try to accommodate that in any of the next 5 days. Okay, once we learn about the neural networks, today we'll be covering with these two. So time series prediction is a challenging task. Why, guys? Because in nature, whatever may happen, okay, if you are trying to predict the stock market, it's not in our hands. Okay, it may happen, okay, it may be exact or it may not happen in the way we are expecting. Okay, it will be complex, but in most of the cases it can be successful. How? Okay, however, with the right techniques and the models, it is possible to make accurate predictions that can be used to make informed decision and improve outcomes in many applications. So imagine if you are holding some stock in the stock market, and if you are predicting some stock is going to go down, okay, you can lose some of the money you are having. So you can take this and make informed decision, and you can play, okay, defensive role in that. Okay, so that's what the usage of this time series prediction. So when you understand, you ought to understand some of the terms. Okay, so I'll be telling you some of the basic terms which will be used in time series data. Okay, we are not covering the entire thing, we are just seeing the very basic level in this time series. Okay, so I'll start with the trend. Okay, what is a trend? Trend refers to the overall direction or tendency of the time series data over a long period of time. So it can be upward, downward or stationary. For example, you are seeing a chart, okay, and you are seeing a graph, like it is plotted from year 2000 to 2023. And what you can see is, okay, you can see a gradual increase in the trend. Okay, from here it is keep on, like it may go high and come down, but at one level, like overall when you see it, it is keep on increasing. Okay, so if that trend is called as upward trend, you can see the trend, which means it is increasing, or it is downward. So it started from high, but when it keep on going, it is coming down. Okay, so that's what a downward trend is. Or if it is stationary, like it is not having any increase or decrease, it is keep on increasing and decreasing, but it is in the same line. So this, it is called as trend. Okay, understood about the term trend? Next will be seasonality. So seasonality refers to the regular and predictable pattern that occur at specific interval within a time series, such as daily or weekly or monthly or yearly. So for example, you are predicting a time series data or forecasting the revenue of, or for example, what can I say? I can tell you about some bus or train. Okay, we are having IRCTC, right? So you are going to predict their revenue. So you are getting their data set, and in that you can find from January to December you are having the data set. And when you see about the month March or May, okay, when you see about the month May, you can see there is some increase in the revenue. So how can you clarify this? Every year in the month of May there is an increase. Okay, when you compare with the other month, in that particular month the revenue is high because it is mostly a holiday period, right? So most of the kids are getting holiday and many are preferred to travel. Okay, so there, or for example, whatever maybe it is, their revenue is increasing on that particular period. What is the reason? Based on the season. Okay, it can be a weather. So when you take about some holiday spots such as Ooty or Kodaikanal or whatever maybe, in that place in particular month there will be high. Okay, why? Because of the season or weather. Okay, or any event occur. Okay, it may increase. So this is what known as seasonality, which you want to understand from the time series data. Okay, and something known as unexpected events. Okay, unexpected events are also known as shock or outlier, can have significant impact. Okay, for example, something like natural disaster or political event may alter the revenue or whatever thing you are predicting. For example, you are seeing some data which is from the year 2000 to 2023. It is from a company's business. Okay, and you are going to predict the future, but in the trend from the year 2000 to 2023, particularly in the period from 2019 to 2022, you can see there is a downward surge, which means it is decreased. Why? Some unexpected event happened in that period. What it is? COVID, right? So we are in COVID and their business got very dull. Okay, so in that period something like these things can happen, and it can be understood from the time series data. So it is important to see these three things in the data you are handling. Clear about these three terms? Can we move on to next one, guys? Trend, seasonality and unexpected events. Okay, so there is some method when you have your data, you can go use some of the algorithms to split into seasonal part, the trend and residual terms. Okay, so we'll see about it later. So next thing you have to understand is nothing but stationarity. Okay, what is stationarity? There is something known as stationarity, guys. If your data is stationary or stable, then only you can go with the time series analysis. Why? So a time series is said to be stationary if its mean, variance and autocorrelation structure do not change over time. So if it is stable, then only you can go for prediction, because that can be repeat and it can be done by the machine learning model. If your data is not stationary, then it is not a good thing to go with that particular process. So in that period, what you have to do is you have to convert your data into a stationary format. Okay, so what is stationary? It is nothing but it has a mean, variance and autocorrelation which is stable, not changing over time. So there are actually methods to check the stationarity and convert if it is not stationary. We'll see about that later. Then going into smoothing techniques. So what is the smoothing? Smoothing techniques can be done, remove noise and reveal underlying trends. Okay, so it can comes under moving averages. Okay, this is moving average is nothing but in that ARIMA we are having MA, right? That is the moving average. Some methods like exponential smoothing or kernel regression are also available. So if your data is not stationary, you can use some of the smoothing techniques to do it. And understand, guys, when we see about the algorithm, I told you, right, we are having this seasonal. Okay, this is some advantage. If you understand your data, just listen, guys, if you understand your data, okay, you are going to explore that data, and if it doesn't have any seasonal change in it, okay, then you want to finalize. Okay, you have to go with ARIMA only. If your data is having some seasonal trend, okay, there are methods to find it. If it is seasonal trend is available, you have to go with this model. Okay, if you are going with this model, you don't particularly have to stationarize it. Okay, it is not needed to be stationarized. Okay, if you are going with ARIMA model, then you have to make it a stationary one. So for that you will be using some of the methods like smoothing and some other methods. Okay, so next thing will be seasonal decomposition. What is this seasonal decomposition? As the term is suggesting, it is a technique used to separate a time series into underlying components such as trend, seasonality and residual or noise. For example, you are having your entire data. Okay, so this may be like this, but you cannot actually see any seasonal trend from this one. So there is a package for this. If you pass this data, it is going to split your data into seasonal one, the trend in it and the residual or noise, whatever the noise you are having in your data. Okay, so that's what the seasonal decomposition will do. So this technique is useful for identifying patterns, because when you've done this, if you find any seasonal decomposition or if you find any seasonality in it, then you can go with this Arimax model. Okay, if you don't see anything, then you have to stationarize it and then go with the ARIMA model. So this technique is useful, and once the time series is decomposed into components, each components can be analyzed and modified separately. Okay, so next going into some deep thing about this stationarity. So finding stationarity in a time series is an important step in analyzing and modeling the data. Okay, as it made the model to easier predict accurate. Okay, and it is important to do it, otherwise your result won't be that much good. So a stationary time series is one whose statistical properties such as mean, variance and autocorrelation structure do not change over time. So there will be constant, and there are few methods actually to check it. One thing is you can go and use a visual inspection. You can plot it and see it. So I'll show you the graph to how to analyze it. Okay, and there is some other method which is known as augmented Dickey-Fuller ADF, in short form test. So this ADF test is going to give you some values, and based on that value you can find whether your data is stationary or not. Okay, so I just want to give you the hierarchy. Remember, guys, if you are having a data set, okay, there can be a trend, seasonality and unexpected event. I'll come from the first. Okay, there are two models in this. So if your data has seasonality, then you can go with the Arimax model, or else you can go with ARIMA model. If you are going with Arimax model, okay, you can go and see the seasonal. If seasonal is present, then you can go with that. whenever you are passing any data into like the time series model, you have to find whether it is stationary or not. If it is stationary, then you can continue. If it is not stationary, you have to go with the smoothing effect, okay, to make it stationary. And how will you find a model is like your data is stationary or not? You can go and use this method, which is nothing but ADF test, okay. And if you are using with, if your data is seasonal, okay, then you don't want to make it stationary, okay. With the Sarimax model, you can directly go without going into smoothing effect or going with this ADF test to check whether it is stationary or not. So if your data is not seasonal, you want to go with the Arima model, you are going to check whether your data is stationary or not. You are going to do with ADF test. So is it clear, guys? We are seeing little bit many terms and then we are just clubbing it. Is it understood for you guys? Can we start how to do this ADF test? Can I get thumbs up in chat box? Waiting for your response, guys. Is it clear till now? So we'll be having a data and you are having two options. Either you can go with Arima or Sarimax. How will you determine? You are going to decompose it, and from that you can analyze whether you are having a seasonal or non-seasonal data. Okay, if it's seasonal, you can directly go with the Sarimax model without checking the stationarity. If it is not seasonal, then you have to go and do the stationary check. And if it is stationary, you can go with the next one. Okay. Yes, I'll be explaining the ADF test now. So ADF test is a statistical test that can be used to check for stationarity. Okay. Why we are checking the stationarity? If your data is stationary, then only you can go with the model to do the prediction in case of Arima. And it tests the null hypothesis. Okay. That a unit root is present in the time series, indicating it is a non-stationarity. So if the p-value, okay, when you actually run this, you will be getting a p-value of the test and it should be less than this 0.05, okay, and there are some other methods too, I'll tell you when we see that actually, okay. If the value is less, then this is rejected, indicating the stationarity. What is this hypothesis, guys? This hypothesis is telling, okay, it is a non-stationary one. If this hypothesis failed, okay, then your data is stationary, okay. This hypothesis, null hypothesis, is telling your data is non-stationary. If you tell this hypothesis is false, then your data is actually stationary, right? Opposite one. So how will you reject this null hypothesis? If your p-value is actually, okay, 0.05, or there are some other method, when you run this, you will get some other values. With that we are going to compare, and if the value is lesser than that values, then we are actually telling this null hypothesis is rejected, okay. So we are going to use this from statsmodel.tsa.stattools import addfuller. So this is the ADF test, okay. You can pass the value and you are going to get this statistic test. This will be the result, okay, and you will be getting the p-value, and if these two values, and finally we are going to get some or other four values, okay. There will be critical values based on the percentage. It will be 1%, 5%, 10% and so on. If these values are greater than the p-value and statistic value, then you can go and tell that your data is stationary. If these statistic and p-value are greater and these values are smaller, then you can tell your data is not stationary. You have to go and do something like smoothing effects. Clear? Clear, guys? You will be getting some critical values, okay. It will be in 1%, 5% and 10%, and this statistic and p-value, if these values are lower than these values, then your data is stationary. If these are greater and these values are smaller, then your data is not stationary. That will be in the simple terms for you guys. So if you are having your data, for example, you are going to use the Arima model and you check this hypothesis and you found that your data is not stationary. So how are you going to convert it into a stationary format? How are you going to convert it into stationary data? So there are some methods like differencing is there, transformation is there, smoothing is there. Every time you do this, you are actually go and do this ADF test, okay. So with that you can compare this value, and if you got some successful result, then your data is stationary. You can go and continue with that one, okay. That's how this thing works. So what is differencing? So this method involves taking the difference between the consecutive values in the time series data. For example, if your original data is yt, which is the first value, or for example take the fifth value, the difference data will be fifth value minus the fourth value. Okay, what is the difference? So when you get difference, okay, the first value obviously will be null, because when you take the first value, it don't have any previous value. You will be leaving that as empty. When you go for the second value, what is the difference for that value? It will be difference with the first value. What is the third value? It will be the difference with the second value. 3 minus 2. Third one minus the second one. What is the fourth value? Fourth minus the third one. Okay. So this will help you to remove a linear trend in the data. Okay. With that, you can actually check for the hypothesis, and based on it, you can check for stationary or not. And then moving the next one, you can do transformation. Like you can take the log or square root or cube root. Tell me guys, in one of the previous classes we have done this transformation, like taking log root or square root or cube root. Where we have done? Anyone remember? In what context we have done? Anyone remember guys? When we have done it? Anyone remember where we have done that method? So I hope we try to see the data and it is skewed towards one side. Yes. So what we have done, we tried to transform it and try to visualize it whether the data is Gaussian or normal distributed or not. Okay. So then moving into smoothing effect, it contains moving average or exponential smoothing. So these are some methods, we'll discuss about it. Moving into the moving average, okay, exponential method. These two methods, I hope it will be clear. These are very basic things. Regarding the smoothing methods, what is moving average method? What is exponential smoothing method? So the moving average is like, okay, as the name itself, it is suggesting the moving average. Okay, every time it is going to move and take some average. So what it is doing? This method involves taking the average of a fixed number of consecutive values in the time data. So it will be a little bit critical, I'll tell you easily. So the number of values to be included in the average is called as window size. You want to mention a window size. For example, if the window size is 2, okay, a 2-period moving average would take the average of the current value and the previous value. So as I told you earlier, this also what will do is, for example, you are having 10 values. Okay, you are having 10 values. So the first value will obviously be 0, okay, because you cannot take the previous value for the first value. So the value for second value will be second value plus first value divided by 2 if the window size is 2. Okay. If the window size is 3, then obviously your first value and second value going to be null, and the third value will be first value plus second value plus third value divided by 3, the average. What will be the value for fourth value? Fourth plus third plus second divided by 3. So it is going to take the previous 3, okay, along with that, okay, totally 3, take the average based on the window size. So it will keep on moving so that it will help you to smooth out the fluctuation in the data and highlight the underlying trend. Understood guys about the moving average? Is it clear regarding this? How this moving average is working? If the window size is 2, then obviously your first value will be 0. So the second value will be second value plus first value divided by 2. That will be value will be placed there. Third value, it will be third plus second divided by 2 and placed in the third place. Fourth will be fourth plus third divided by 2 and placed in the fourth place. When you go for exponential smoothing, okay, this method is similar to moving average. Okay, it is going to, you are going to set the window size, so it is going to take the previous value, but here you are actually taking the average. Okay, you are giving equal importance. You are taking the fourth, like if you want to find the value for the fourth one, you are taking 4 plus 3 divided by 2. But in exponential smoothing, what you will do is you will assign more weight, okay, to the recent value and the less weight to the older value, which means you will take majority of that place. For example, if you take 4, okay, fourth value, you will take 0.75% of the fourth value, and what will be the third value? You will take 0.25% based on giving weight. Okay, with that you can actually place more weight on that particular point. The exponential smoothing can help to capture the trend and seasonality in the data while also smoothing out noise and fluctuations. So these are some of the smoothing methods. As I told you earlier, we can set the window size, you can just do it with the help of dot rolling, guys. You don't want to do any specific task, you can do it with pandas dot rolling. Okay, you can set the window size, so based on it, it is going to do. If you mention the window size as 10, then obviously the first 9 value is going to be 0 or null, and the 10th value will be the combination of the previous 10 values divided by 10. Okay, so this is how you will do the moving average. And then regarding exponential smoothing, okay, you have to import a package for it. You can do it manually. This will be easy. From statmodels.tsa.api, import simple exponential smoothing. The alpha value will set the weight. Okay, so we can fit it and transform it for further process. Okay, guys, can we see about little bit about the model and go into practical example? Can I get thumbs up, guys? Once again, waiting for your response. So regarding this ARIMA model, okay, auto-regressive integrated moving average. So it is based on moving average. Okay, so a commonly used model for time series forecasting that combines the AR, auto-regressive and moving average components with difference to make a series stationary. So this should be stationary, guys. Okay, when you go for seasonal one, okay, it take into account the seasonal components of that time series. So it is based on that seasonal, so that it will be little more accurate if you have a seasonal data. So ARIMA model will be having 3 parameters like P, D and Q. Okay, and there are respective things about it. When you go for Sarimax model, okay, so this uses the seasonal data, and this can handle non-stationary data. Okay, your data don't have to be stationary. It can handle the non-stationary data. Okay, because it is using autocorrelation and seasonality pattern in the time series data, and residuals are typically used to access goodness of a fit of a model. So it will get a good fit for you guys. So I hope we can start with the project, and then we'll continue with the assignment 3, guys. Okay, so now itself I'll tell you the assignment 3, so make sure you are noting it down. Okay, once we complete that, I'll tell you about the project. Can we go and see this, guys? Assignment 3. So I hope in the assignment 2 you have used the car price prediction data set. Okay, use the car price. You have done the exploratory data analysis, pre-processing until the train test split. Am I correct? Okay, if you haven't done it, please do it. When you come till train test split, okay, now you can imply some of other things, right? What are the pre-processing you can do? You can scale the values, you can encode them, you can select, you can do feature selection or feature extraction with PCA. Okay, all these things you can do, right? So do all those necessary things you can perform. Okay, perform EDA, necessary pre-processing, split the data into train test split, then go into the machine learning problem. So this, what it is a classification or regression problem, guys. You are going to predict the price of the car, right? Used car. So it will comes under classification or regression. So this is a regression problem. Okay, so choose different algorithms and try to get the best performing model. Okay, you can go with the R2 score, right? Yes, correct, it is a regression. So once you get some good model, okay, try to make it. Use 3 to 4 models, and when you complete it, try to build a predictive system, guys. Okay, if you have doubt, you can go and check the previous class videos. Okay, and try to complete this project, and the time I'll be giving you 2 days for this, guys. 2 complete days, because you have already completed these 2 tasks, right? So you just want to continue with the algorithms or do some more pre-processing. Try to get high improved accuracy in this model and build a predictive system, so that every time the user runs, it should ask what are the details of the car, that will be your feature, and then finally you have to give the output what can be the price expected. Okay, I hope it will be clear regarding the assignment 3. Today is day 15th class. Okay, day 16 and 17 for you guys to complete the assignment. 2 days. By day 17, I will be circulating the assignment 3 update form, so that please try to complete this, guys. Okay, it will take little bit 30 minutes to 1 hour for you to successfully do this. So next, going into the project. Okay, so I'll import the necessary libraries, and we are not going to predict the stock price today, guys. We are going to use a monthly beer production in Australia. Okay, this is a company, they are producing beer, and we are going to analyze their data and do forecasting. So I'll load the data. Okay, this is from the 1956 they are having the data. Okay, so since we are going into time, okay, I'm just converting using pandas date time df dot month. I'm just passing this, and now I'll set this as an index. Okay, because I want this date time as the index to compare the beer production. Okay, this will be the value. So this rolling statistics, it is nothing but moving average. Okay guys, don't get confused. And I'm just setting the window size. See here, I'm just setting the rolling. I'm taking the mean value, I'm checking the standard deviation, and I'm plotting them. So if I run this, okay, so we got the result, but every time I get this error, I'll try to clear the runtime. One minute guys. So let it connect. I imported the necessary libraries here. You can check about it. Okay, I hope day 18 will be fine, right? If you are having exams, I understood the reason, but I hope we can have till day 18. Okay, after that we cannot go. Okay, that will be nearly end of the session, right? So we are having only 5 days left from after this class. Okay, so now there is no issue, right? So there is some issue with the Google Colab. Sometimes when I run this, I am getting that unnecessary error. So going with this one, okay. So what is the original value? You can see it guys. This is the original value over time. Okay, this is from 1955 to 1995. Nearly 50 years, 40 years. Okay. So it is going, and when you take the rolling mean, okay, which is you are trying to smoothen it. Okay. And this is what the value. And when you take the standard deviation, you can see it here, very low. And now we are going to check the stationary. How can we do it guys? First I'll plot it. Okay, this is our data from 1955 to 1995, and you can see, okay, it seems like it is increasing at some point. So this can be a seasonal data. So for that you have to do the seasonal decomposing, then only you can understand, right? So what I'm going to do is, I'm going to use this AD Fuller. What it is? ADF test, right? So I'm just plotting them and doing this ADF Fuller test. Okay, I'm passing the values. I'm taking the test and I'm getting the 4 values which I told you. Okay, we'll be doing some test here. So if I run this function, see here, I'm passing this monthly beer production, and what I got, let it run, and this is what we got, the same thing. And below that you can find these values. Okay, this test static value, p value, critical values. Okay, and based on it what you can see, this critical values are low, which is in negative time, negative. Okay, and this p value is greater than them. So if this is the case, then your data, and visually you can understand this is not stationary. Okay, there is no stationarity in this data. But now you want to check, okay, you have to decompose it. Then we are going to pass this seasonal decompose. Okay, we are going to use the add method, and we are trying to get this in A. Okay, if I run this, so this will split our data into seasonal part, which I told you earlier. So if our data is seasonal, then we can go with Sarimax, and there is no need for you to go with stationary, convert them into stationary one. Okay, but see here, so this is our data, and this is the trend. What is the trend? You can see, right, it is increasing. That's the trend you can see. So how I got this guys, I just passed my data set to seasonal decompose. It will give me 4 things: my original data, the trend, seasonal, and residual. Okay, I just plotted it. This is from Pandas. You can plot a data frame using dot plot simply. And see here, the trend is increasing. And what this is suggesting guys, this graph, okay, if this is a flat line, okay, if you got the seasonal as a flat line, then there is no seasonal trend. But this is a seasonal trend guys. There is some seasonal trend with this. So you can accommodate Sarimax to do this. You don't want to go any smoothening effect. Okay, and we can find the residual values here. So I'm going to just plot them once again into a single graph, seasonal, trend, and residual alone. Okay, this is the seasonal, the trend, and the residual values. Okay, so we are going to go into the forecasting models. So we are going to use this Arimax model. Okay, so this is a type of Arima model, but it will be some more advanced. So I'm going to split the training data. So I'm just taking, like, I'm going to take few of the, like, totally we are having some columns. Okay, for example, df dot shape. I'm just going to leave the final 12 things for testing. Okay, totally 476. I'm going to store the training and testing data. I'll load the model from statsmodel.tsa. Okay, state space Sarimax, import Sarimax. You have to create an object for it, and I'll pass the data set inside. And this, you have to pass some of the features, guys, order and seasonal order. And to find this, there are some more complex things are there which we cannot cover in this class. Okay, if it will be furthermore collapsing for you. So there are some methods which we will try to cover if possible in future classes. Okay, so this you can do. There are some methods to find it, or you can go and try different combinations using a for loop and get actually a best fit. So once you imply these things, you can go and fit the model and get the summary of it. So if I run this, it is going to take some time because it is a little bit big. So our data is from 1955 to 1995. So this is how you can do also with the stock market also. Okay, so we'll wait for it to run. So main thing in time series is you have to check what you have to check. This data should be stationary, right? If your data is not stationary, just go and check the seasonal. If it is seasonal, you can go with the Sarimax. If it is not seasonal, then only you have to go for some other methods to change it. Okay, so this is a summary of our method. What is the time when you have done it? Okay, what all happened there? Okay, you can get a bunch of these values. So once you done it, you can use it for predictions. Okay, so I'm just going to pass some other values for prediction and get this in this variable. So this is the prediction result I got. Okay, so now I'll plot it. See, guys. So this is the prediction based by our model. Okay, the blue one will be the original value. The orange one will be the prediction by the model. So it is trying to do, but it is not that much accurate. It is accurate in some parts, right? Can you see it, guys? Can you see the trend here? How it has happened? We have used the Sarimax model and we have plotted the result, and these results, okay, you can actually go, okay, you can calculate the error. So we'll come to this one. Wait, guys, so I'll pass the error. This is like regression, right? So we can calculate the mean squared error, root mean squared error, the mean value. Okay, so I'll plot it again. Okay, from the time series, you can go and check some of the individual values. Okay, from 1994 to 1995, if you take that part alone, how it is happening, you can see how it is fitted. Okay, and then see this, guys. So I'm going to create a new column in our thing. So if I go and check this test data, see here, this is the monthly beer production, this is the Arima prediction. Okay, it is tried to predict. This one is little bit 10 values less, but when you see here, this one it tried to predict little bit near, right? Compare this 160, the original value, this is the predicted value. Like this it is predicted. Okay, so this is what a time series analysis is. Okay, so you can explore this furthermore, and you can also imply the algorithms also, like neural networks, deep learning. So when we complete that, we'll try to accommodate that also in further class with some other different project. Okay, guys, is it clear? So I hope it will be a lot actually, because there are many different terms and new terms you want to understand if you go with the time series analysis. So that's why I just given you a basic example with just an introductory part. Is it clear, guys? Can we wind up today's session? Interesting, right? Regarding the time series, you can actually use it for stock market predictions or some other price prediction or their revenue prediction based on the time series, based on the past data. You can predict or forecast the future. Okay, the assignment 1 update link which will be present in day 7 or day 8, guys. So please check that and check the live. So you can find, or you can find it in the description. okay, where you can take that link and try to update the assignment. So thanks for attending the class, and make sure you are completing the assignment 3. Okay, take the car dataset which you have completed in the day 2, try to build, okay, incorporate models and try to get a best model, and then build a predictive system with that. I hope it will be clear. Thank you guys.